We'll do some more examples. Of logarithms. So the structure here, we're going to call this example 7. I got a problem that says 1/5 raised to the x equals y. And they want me to convert this into a log form. To convert this into the log form, I have to ask myself, what is my base? I have a base of 1/5. So I can say log of 1/5. The solution or the answer to the problem is y. So that comes immediately after this. Equals, and it's always equal to the exponential value. The exponent here is an x. Do another quick one of this, example 8. It says b to the a is equal to 123. To convert this into a log structure, you would say log base b, that's your base. Answer was 123 is equal to a. So all I'm interested in today is you learn how to use this structure of logarithms. We're going to build on this. So example 9, it says log base 4 64 equals, and then that's your question mark. They want you to fill out this. So as you learn how to read this, you would say 4 raised to what power is 64? That's what you have to ask yourself. 4 raised to what is 64? 4 squared 64? No, 4 squared 16. 4 to the 4th is 64? 4 times 4 times 4 times 4? I don't think that's going to work. That's going to be 256. So if 4 squared wasn't it and 4 to the 4th wasn't it, what about 4 times 4? 16. 16 times 4 is 64. That's an exponent of 3. So it's going to test your knowledge with that. Now there's a way to figure these out on the calculator, but I'm not ready to teach that to you. I'd rather you do the guess and check because this is a good exercise. You should be able to do your exponents in your head. And so let's go to an example 10. I've got, let's see here, what we got here? Log base 5, 125 equals what? Now that one's a little easier. 5 times what? How many times do you multiply 5 to get 125? So 5 times 5 is 25. 25 times 5 is 125. So it says 5 to the 3rd is 125. So your answer here, once again, is 3. How about, oh, let's see here. Example 11. I'm looking off of a worksheet here. I've got log base 6 of 216 is equal to what? So when I'm looking at this, once again, I have to basically just recognize the structure here. It's saying 6 raised to what power is 216. So 6 to the 1st is 6. 6 to the 2nd is 36. 6 to the 3rd, 6 to the 3rd. Now, if you're going to use your calculators, I'm giving you the method here. Clear out my calculator here. I would go 6 raised to the 3rd, and I see that that is 216. So I just start listing these out until I get to them. And then once again, this would be equal to 3. So it's log base 6, 216 is equal to 3. So we got a bunch of these where they were equal to 3. Let me do a couple more of these real quick. We'll call this example 12. I've got one that says this. Log base 64, 4 equals what? So as I look at this, I have to ask myself, 64 raised to what power gives me 4. Now if your base is bigger than your answer, chances are this is going to be a radical or a cube root or something like that. It's asking, how does that 64 get broken down to get you to 4? Because you're not raising it to a power. If you raise it to the first, it's already 64. Squaring it and cubing it, that's just going to get bigger. So it must be a root. And so you could start running through those. Again, you may have to go to your calculator. And as we looked at in a previous example, 64 raised to the 1/2. The 1/2, when you go up to a fraction, that's a root. So I could do a square root 64. That gives me 8. So that's not quite big enough. Let me do a cubed root, which in my calculator, if you can see my calculator here, I don't have to use that square root. I can actually raise it and then just put it in as a fraction to the 1/3. And that's what gives me that 4. 64 to the cubed root is 4, which is equivalent to saying the cubed root of 64 is 4. And you may have to play around with that a little bit until you get comfortable with that. Kind of a new concept using fractions as exponents. So for this example 12, I've got log base 64, the answer was 4, and the power that I needed was a 1/3. And I don't want those as decimals, I want those as fractions.